All right, today we're looking at graphing systems of linear inequalities. So instead of just having one inequality to graph and shade, we have two, and wherever their shading overlaps, that is the solution to our system. So we have 2x plus y greater than -5, 2x minus 2y greater than or equal to -6. We need to put these into y equals or slope-intercept form, so that way we can graph these. So I'm going to come down here. Here's my 2x plus y greater than -5. We need y by itself, so we'll subtract 2x. So we have y is greater than -2x minus 5. Things I need to remind myself on is this is going to be a dashed line because it is just greater than and it's not equal to. So if I go ahead and graph that one, we're going to come down here to my y-intercept of -5. It has a slope of -2 over 1, so we'll go down to right 1, down to right 1. It can also go up to left 1, up to left 1. Okay, and then you can use your handy-dandy ruler or ID to make sure your line is oh so beautiful, reminding ourselves that this is a dashed line because it's just greater than, so we will dash this guy. And there's our beautiful first line. Then we come in and we've got our next one. So we have 2x minus 2y greater than or equal to -6. We need to get y by itself, so we'll subtract 2x. That leaves me with -2y greater than or equal to -2x minus 6. We need to get y by itself, so we're going to divide by -2. We need to remind ourselves that when we divide by a negative, so anytime we divide or multiply by a negative, my inequality symbol will flip. So this will be y is now less than or equal to positive x. -6 over -2 is positive 3. So y is less than or equal to x plus 3. This is going to be a solid line. So we're going to come up here to positive 3. And it's got a slope of 1 over 1. So it's going to go perfectly through my diagonals. So we will draw it in beautifully. It's a solid line, if you remember. Okay, so now we need to work on our shading. I love 0, 0 because it's easy to plug in. Luckily for us, neither one of these plug into 0, 0, so I'm going to test 0, 0 into both my equations. Always go back up to your originals to see if it works. So if I plug in 0, then we'd have 0 plus 0 is greater than -5, which 0 plus 0 is greater than -5. So we know at least for my dash line, this side is going to be shaded. Okay, and I'm going to shade kind of everywhere so we remember which way it goes. And I'm going to do it lightly until I know where my overlap is. So then we plug into my second equation. So if I plug 0, 0 into my second equation, that gives us 0 minus 0 is greater than or equal to -6. Well, this happens to work in that equation as well, so it works in both of them, so that means I would shade this way. Now, they happen to overlap here where 0, 0 is, so that's where I'm going to darken in my shading, is where they overlap. Okay, so then you just kind of figure out from there. So if this second equation was a no, then that means I would shade above, so then my overlap would have been here. So I just kind of lightly go in, lightly shade in the direction that it goes to see where they overlap, and then I just darken in that area and make it look oh so beautiful so you know what your answer is. Alright, so put them into y equals. Make sure if you divide by a negative, you flip your sign, test a point to know where you're going to shade, and shade in the overlap. Where the overlap is your solution. So any point that I find here in my overlap would be a solution to this system. So like if I wanted to know is, -3, 3 a solution, then we would come up here, we go to -3, 3. Here's the point, -3, 3. Notice that is not in the shaded region, so that would be a no. If we wanted to know if, let's look at 0, -5. So is 0, -5 a solution? So if we go down here to 0, -5, here's 0, -5. It is on my line, but if you notice, this is a dashed line. That means it does not include that. So because that is a dashed line, it is not a part of my solution because it does not satisfy this top equation. So we would say no. And if you want to remind yourself, it's on the dashed line. That's why it doesn't work. Same thing here. If you look at this point, that intersection point, because there's a dashed line there, that would not be a solution. But any point you choose in here, so if you choose 3, 1, is 3, 1 a solution? Well, 3, 1 is somewhere in here in this chaotic mess. It is in my shaded region, so most certainly, yes, it would be a solution. So that's kind of what that shaded region means. Anything in there, whether it's near the line, far from the line, anything shaded or on a solid line is a solution.